All right, guys, so we're going to be starting on our water notes, specifically water cycle. So you're going to want to have your water cycle notes out in front of you and be ready to write down some definitions. All right, so the first question I just want you to think of is, since we're talking about water, is where did all of Earth's water come from? We kind of covered this in a previous unit, so I want you to think about it and make your prediction about where did the Earth's water originally come from. And then afterwards, pause it and watch this video that's going to be attached underneath here, the first minute Earth, and see if you are correct. So we're going to be talking about the water cycle. I'm sure a lot of you are familiar with it, but there's going to be some more terms that you probably haven't gotten to before, such as transpiration. Okay. Well, let's talk about it. Please write down our first definition, which is over here. The water cycle is the continuous movement of water from water sources, right? So water sources could be lakes, rivers, streams, oceans. So it moves onto land, into sometimes seeping into the ground, sometimes just running over the ground, and then back to other water sources. In that time, it can get cleaned, it can get recycled, it could lose its salt. All sorts of things can happen to it. It could pick up dirt along the way and weather and erode on its journey. Right? So water evaporates and moves upward like this. It will travel the cloud over here. When it reaches a certain point, it will become so heavy and so saturated, filled with liquid, that it will start to fall down. Gravity will overwhelm it and pull the water droplets down, or if it's cold enough, snow down. Eventually that melts and it moves downward on this downward slope, creating sometimes rivers or streams, and then that water either seeps into the ground or goes back into other water sources. So that's the water cycle. So the oceans are one of the best ways to feed the clouds, right? All the evaporation comes up and it feeds these clouds over here. The clouds are just traveling. They are incredibly heavy, but not super dense. So they travel over here, and when they reach a mountain, the mountain oftentimes pushes them upward. They have nowhere to go except upward over the mountain, and when that happens, even if there's an invisible cloud here that you don't see how these clouds are just kind of coming into existence. That happens when they get higher up in the sky, because higher up, as altitude increases, temperature decreases, and it needs to be cold enough for the clouds to form. So mountains are key in creating clouds. So our first definition that you're going to write down is evaporation. So water, after water cycle. Evaporation is when water molecules that's in liquid water escape into the air as water vapor. So the liquid changes into a gas. It is a phase change. You can kind of see this taking place on the water. Generally, this is an invisible process that you don't normally see. However, in this case, it is so cold in this area, you could tell that the water, as it's evaporating, is also immediately condensing on whatever particles are in the air, and that's why it's forming a very low-level cloud that we sometimes refer to as fog. So evaporation, one of the first steps of the water cycle, it's what feeds the clouds. You can see another example here. The warmer that it is, there will be more evaporation that's taking place. You're not always going to see it, but if it's a little bit chilly, sometimes you can as well when you start to see it condense right over here. So you can see this cycle taking place over here as the water comes upward. This happens because of the sun, right? So the sun's rays come down and the sun's rays hit the water. And basically all these water molecules are connected. They're like holding on to each other for dear life. They're all connected together. But what happens is that the sun, after it hits it, that heating it up causes it to move. And then these are two water molecules, they separate. And then one of them might fly upwards because it's so much less dense, it's not connected to anything. And that is what causes it to rise up and go into those clouds. So it's the sun's rays that's causing the bonds to break in between them. So you can see right over here that the cohesive forces that keep the molecules together break apart during evaporation. And that's what sends these invisible water droplets up into the air. Remember, it's no longer water droplets. Instead, it's now the gaseous form of water, which you should know as water vapor. Next definition I'd like for you to write down is crystallization. So when a body of salt water dries up, minerals such as gypsum and halite are left behind. So this is an underrepresented part of the water cycle that not a lot of people talk about, but we will. You should be making a connection here to a previous unit. There is another type of rock, or a specific type of rock that we learned about, halite and gypsum. So if you guessed it right now, good job. We're talking about chemical sedimentary rock. Remember, water is a chemical. So we can see right here, as the water cycle goes down, precipitation comes down. Now, there is going to be some salt, or at least the building blocks of salt, of sodium, inside of the rocks. And as the water comes down and weathers and erodes away the rock, you'll see it come down right here. It picks up that salt, and then it drops off that salt into liquids. Now, eventually, over time, that salt will either dissolve in there or settle down at the bottom, but the water evaporates over time. And if all that water leaves, what's left is all the salt deposits that were left over. Because as this water evaporates, the remaining water becomes saltier and saltier and saltier until it's all just salt and no water that's left. Doesn't always happen, but it could. And then that's how you get the crystallization that takes place. And we have one final definition of the day, and that is transpiration. So evaporation sends water up into the air. Transpiration also sends water vapor up into the air. This is the other way that water vapor can escape up into the air other than just evaporation. So in transpiration, right, you see that the water first gets absorbed into the plant. It doesn't do that through its leaves. There's actually microscopic openings on the leaves, but that is not to absorb water. If you are watering plants like that, it's not very useful. You have to get it into the ground, right? And then the plant can absorb it through its roots. Now, plants generally take in more water than they actually need. So it's almost like they need to release some of that water. Have you ever maybe had too much water that you didn't need and you needed to let go of some of it? Think of it like that for plants. But instead of it coming out in liquid form, it comes out in gaseous form. So it has tiny little pores, openings inside of the leaves, and it basically releases that excess water vapor through there. Now that that water vapor is up here in the air, it is going to rise up and form into clouds as well. So it's the process by which plants release their water vapor into the air through their leaves. And sometimes it's referred to as evapotranspiration because it's still transpiration, but it shares so much similarities with evaporation as well, because both of those things are contributing to basically all of the water vapor that's going up into the air. So afterwards, I have two quick things for you to watch. This cool video that talks about which came first, the rain or the rainforest, and a clip from Planet Earth that I'd like for you to watch. And there's also, if you're curious, an episode of Planet Earth 2, if you can find that somewhere. They have an episode called Jungles, and there's a really cool sequence in there about these forests creating their own clouds. All right, thanks, guys.